So this video is totally unplanned. I've been interested in looking at the divisibility of polynomials recently because I've been taking a course known as Rings and Fields. You look at the divisibility of polynomial rings, and I just got interested in doing a few examples for you guys. So we are going to take a general case for the quadratic on the real numbers, x squared plus 4x plus 4. We're going to divide it by x plus r, see what happens. Of course, we know that there are actually two factors, x plus 2 and x plus 2. So we might be able to yield it. I'm not too sure. I have not prepared this video whatsoever, so this is a bit of a impromptu video. So first things first, how many x's goes into x squared? Well, x's goes into x squared. X times x is x squared. We can now subtract x times this. So that gives me minus x squared minus xr. And now we subtract from this thing. That is actually going to bring us down to a second order polynomial. Sorry, I think it's first order. Yeah, it's going to be linear. So that gives us 4 minus r x, and of course we have a plus 4 here. Okay, and now we can do the same thing for this thing. We go, okay, how many x's goes into this thing? Well, it's 4 minus r, so we add 4 minus r. Okay, so now we have this. It's pretty simple stuff. The next problem is we actually have to subtract, and this is where things are going to get a bit messy. Not so much hard, but just messy. We have to subtract x plus r and multiply by 4 minus r. And let's just go ahead and do the expansion over here so it doesn't get in the way. We're going to get minus 4x plus rx. Wait, let's make sure I'm doing this right. Yeah, plus rx minus 4r and plus r squared. Okay, so let's go ahead and actually expand this as well. So this is 4x minus rx, and of course we have an additional 4. So now we can just go ahead and subtract. Let's go ahead and actually subtract them from one another here, since I've got the factors over here anyway. Let's use our red pen to guide what we're doing. So we're cancelling this 4x with minus 4x. This rx actually cancels, which is fairly nice. Let me make sure that is right. Plus rx minus rx. Yeah, that is right. So we have a remainder of 4. And so, I want to return to the blue. So we get r squared minus 4r plus 4. All right. Now, where does this get us? It pretty much gets us to our original sort of equation that we were looking at, apart from the fact we have a minus 4r, which I'm not even sure if that's right. Yeah, that's right. So we know that this can be factored into r minus 2 squared, and so we can actually go ahead and we write this as x plus r multiplied by x plus 4 minus r, and we add r minus 2 squared. That is our polynomial sort of factored into its factorized sort of form when we're dividing by x plus r. And if you were to take r to be 2, you should find that actually so if we took r to equal 2, then this thing here, the remainder would go to 0, and that shows that that is a factor, x plus 2 is a factor of this quadratic. And essentially you get the x plus 2 term, which is what we would expect, and we actually get another x plus 2 term, so it actually gives us both the linear factors. But let's see what happens if I say r is equal to 1. Then we just replace, and we get x plus 3, because 4 minus 1 is 3, and we get a addition of 1 minus 2, which is minus 1 squared, which is 1, so we get this beautiful beast. We get, yep, that's right. Yep, so that is for r is equal to 1. It would sort of look like this sort of thing here, and that would sort of resemble completing the square in a way, but really it's not completing the square, because if you're completing the square, you'll just get basically this as x plus 2 squared, because it is factorizable. But yeah, so let's prove that it actually works for r is equal to 2. R is equal to 2, you get, okay, well, we get x plus 2, x plus 4 minus 2, and 0 squared. And that gives us x plus 2 multiplied by x plus 2. And that goes to prove that x plus 2 does divide x squared plus 4x plus 4. So, pretty interesting case right there. Let's go ahead and see what happens if I do something similar with a irreducible polynomial. Let's say x plus r divides a easy one, x squared plus 1. We know that this has no real roots. The only root is plus or minus I, of course. So x goes into x again, multiply, subtract, and we get minus x squared plus rx. Of course, that cancels, so all we get is 1 minus rx as our remainder. This is it our remainder though? That's our question. Well, essentially the answer is no. It's not our remainder, because r goes into x basically. So we can write this as x minus r. And we multiply again. We subtract, sorry about this, I did not leave enough room, but I'm not going to, oh, maybe I will. I'm going to erase it. I'm going to erase it. Who loves clean notes? Me. So we get minus rx and minus r squared. That's just due to the fact there's a minus in front of this this r term. And of course, we realize that these two are going to cancel, and this is going to become a plus. So essentially we get 1 plus r squared. Which is essentially, as you can sort of see, is actually our quadratic back. So our remainder is the original sort of quadratic in a way, but r is a different number, essentially. So this gives us the form x minus r, x plus r. Oh no, not the battery. I just got this thing. X plus r. I just got this thing out. Well, I'm just going to have to get more batteries for it, I guess. But we also add 1 plus r squared. And of course, we can expand this to essentially verify that that is true. Which it will be. Let's do it. So x squared minus r squared, because we have the difference between two squares, and plus 1 plus r squared, which is equal to x squared plus 1. So that is a factorized result, and that also, if we test some r values, real r values, essentially you'll realize, well, the remainder is never going to be 0 because 1, r squared is always positive, and that is basically it. R squared is always positive. If this was an r, if this was just r, not r squared, or even r cubed, then we'd have a possibility of finding a remainder that is 0. So that goes to show that there is no linear factorization in this form that divides x squared plus 1 in the real numbers for, this is important, for r is in the real numbers. Okay, so guys, I hope you guys enjoyed this quick impromptu video. This is part 1 of factorization of polynomials. Remember to subscribe for more, and I'll see you guys in the next one. Bye bye, buddies.